Okay, in this quick video, I will show you how to test sort of one of the main implications of these different models relating proportional representation and sort of government spending levels. And what I will do is I've gone before to the of the University of Gothenburg and downloaded the data set that we used in the first section, and it's under the data archive. Here's the code book, which I've opened already. And there's the cross-section ETA dataset, which we'll be using. And I've downloaded that before. Here's Stata. I've opened up Stata. It should be the same version that you have. And I will open the dataset. So I have to find wherever I saved this, which is not here and not here, but here. And there's quite a few versions of this already. So I will open the QRGs, the STD CS Gen 18 dataset. And as you can see here on the right, all these variables have appeared that we've already used before. And what I would like you to do now is basically I would like you to sort of, if you have a second screen or if you can sort of fit it on the screen, follow the steps that I'm doing. But if you can't do that, I would recommend you pause in between and sort of follow the steps. In terms of the commands that I use. There's really no alternative to sort of doing this yourself. Just watching it once is not gonna help you. So follow along if you want. Remember, we left off with looking at the spending variable, which we knew from the code book was called IMF-EXP. So this is not something that I memorize, but you know, there's all these cryptic variable names, and if you look for spending, maybe we can find it. No, we can't find the expenditure. Maybe there's IMF-EXP. Something. Okay. Commands we've already learned is the summarize command. So we can type this again: summarize IMF-EXP. That's the variable name. We could summarize something else, banana, but there's no variable called banana. Yeah, there's no variable like that. But there's a variable IMF-EXP in the dataset. And if I hit enter to typing this into the command line, I get this sort of rather sparse bit of information about the this variable that I was interested in. Now, what else can I do with it? Well, maybe I want some more information. So I can see here that there are 185 observations with an average of 33.5, a standard deviation of 12, and the smallest is 12%, and the highest is 102%. Not sure how that works. I think it's some weird, it's like Libya or something during the war. So what else could I do? Well, I could ask for additional details. So I could type the same summarize command, summarize IMF-EXP, and add a comma, yeah, right afterwards or there, and then type detail. And what that does, if I hit enter, is it gives me additional information. Some of these things should be familiar. So these are percentiles, you know, the 99th percentile and the first percentile and the 50th percentile, so the median, lots of things, and some additional bits of information about how this variable is distributed, basically. But sort of looking at these numbers is not very intuitive. Humans are not built for processing numerical information. We are sort of, you know, built for processing graphical information. So we should graph this variable out that we're interested in. We're interested in spending as an outcome from, you know, electoral rules, for example, or last week we talked about inequality. So what we'll do is we'll draw a histogram. What's a histogram? Well, a histogram basically plots the variable over sort of its own values, sort of using you know, bins that capture some range of the variable and sort of distributes how it is distributed. So let's type a histogram. I think everybody has seen one. Histogram IMF-EXP. Enter. And what that gives us is basically a histogram that comes here, which tells us that most countries sort of fall in this sort of 30 kind of range, right? And there's very few countries with a government expenditure level as a percentage of GDP over 50 or 60 or so. There's a few sort of outliers on the right, and it is obviously censored at 0. So that's a more informative kind of piece of information, and we could modify this as well. If you're interested in that, you can ask me. I can tell you how to do that. Another way to look at this is using what is called a kernel density estimator. Now, this is something that probably none of you have heard about, and you don't really need to understand the details of how it works, but basically it lets you sort of plot a smooth distribution of what that looks like. So we could type k-density IMF EXP. If you're interested in the sort of math behind it, do it, have a look. But it's basically a nice way to distribute, to look at the distribution of this variable. So we do that, and we get sort of a similar kind of distribution, obviously, because it's the same variable, but it tells us a little more sort of how that looks, especially if you have kind of smooth data. So that's quite informative. So we know sort of what the distribution of government expenditure levels overall looks like. We have learned enough about IMF expenditure variable now, I think. So let's look at the proportional representation variable. So we'll have a look in the code book here. So if you search in the code book for proportional representation, you will find, so I did that before, proportional representation, and there it already pops up, and there's something called DPI-PR, proportional representation. And if we click on the page and go to this thing, it actually says 1 if candidates are elected based on the % of votes received by their party, and if sources specifically call the system proportional representation, and 0 otherwise. That sounds very much like a PR system. And then we have here also a sort of coverage map, and that is quite impressive. So there's 161 countries for the most recent year in this data set. That's 2014, but it basically covers all countries of the world. Okay, so let's remember, what is the name of the variable? DPI-PR. Let's remember that and have a look at what this looks like in the data set. So what can we do with this? Well, we have learned the summarize command, so let's use it. And we can abbreviate this to sum, actually, so we don't have to type summarize out every time. So sum DPI-PR, what does it give us? Well, it gives us the mean. But we've kind of learned already that just in the codebook that this is a variable that is 0 and 1s only. So the minimum should be 0, the maximum should be 1. And what does the mean give us? The mean should give us a percentage or the proportion of 1s, right? And that's exactly what we get. So we get 161 observations. The minimum is 0 and the maximum is 1. There is only 0s and 1s really. And the average is 62. Or 62.7, and that means that 62.7% of these 161 countries are PR systems. But of course, some of these are non-democracies, so keep that in mind. Okay, a better way to display information that is categorical variables like this proportional representation is only 0 or 1, or sometimes you have variables that are 0, that is like types PR systems, for example, or so, would be to sort of tabulate it and to make a frequency table of this variable. And for that, we use a command that is called tabulator. So, and that's quite convenient. So tab or tabulate DPI PR. Let's do that and have a look what happens here. And that tabulates nicely what kind of what this distribution looks like. So there's 60 zeros and 101 ones. So 62.73% are PR systems. That's the same as the mean that we got here, obviously. And so that's a nice way to sort of summarize this information in a categorical variable. Like I said before, graphic representation of data is always more helpful. So what we can do is we can make a bar chart. The command for the bar chart is unfortunately a bit more complicated. We can use a command that's called graph bar. So far, so easy. Okay, so that's good. That's understandable. But then something weird happens. So we have to do a comma, and then we have to do an over. And then we have to attach parentheses to the over, and into those parentheses, we type the variable that we're interested in, DPI-PR. That's really annoying, and I understand that that's not That's not so nice, but this is how the command works. Okay, so graph bar comma over, and then in these parentheses you put the variable name, in this case dpipr. So we hit enter on this, and what we get is sort of a bar chart that displays the same information that we already saw before. So most countries are pre-R systems in this data set. Let's close this again. What else can we do? Well, we could, for example, what would happen if we, now what was it that we try a second? So we were interested, of course, in the difference in spending level, expenditure levels for proportional representation and majoritarian systems, right? So in a way, those are averages, right? What's the difference in the average spending between PR and non-PR systems? So how could we get at this? Well, we basically already have the tools for this. So we know that the summarize command gives us the average, right? So we can do sum IMF EXP, and that gives us the average of the spending overall. And what we can do in Stata, of course, is basically provide a sort of if condition. So we can summarize this variable IMF EXP. So I just got this back by pressing the page up button, by the way. Page up and page down lets you recall this command. So sum IMF EXP if something, if what? Well, if dpipr equals, and there's a double equal sign, it's another thing you may be not used to, equals 0, for example. What is that going to do? Well, it is going to summarize the IMF EXP variable. It's going to summarize this variable, so it's going to give us the mean and so forth. If what? If the dpipr variable that we looked at before here is equal to 0. Yeah? So for these 60 observations that have majoritarian systems, we get the spending data. So let's do that. And we get an average of 28.75 for 59 observations. What happened? Well, we lost one observation because we don't have spending data for this clearly. Then we can do the same thing. So sum IMF EXP if dpipr is equal to 1. Hit enter. And so here we have 99 observations. Again, 2 are lost here compared to this PR variable. So for 99 observations, we have an average of 34.5. And this is basically reproducing one of the tables from the Tabellini, Persson and Tabellini, of course. But but the outcomes are actually quite similar. So 28% average government spending for majoritarian systems and 34.5% average government spending for proportional representation systems. So in this way, there's some support for their hypothesis, I guess. What else can we do? Well, we could graph this, of course, and this is where the graph from before comes in handy. So we used here you see we used this weird graph bar over dpipr, right, which was just a bar chart of dpipr, just of the frequency of dpipr. But we can basically use the same syntax, graph bar, for looking at averages of other variables over something else, over PR variable, for example. So graph bar IMF EXP, comma, over dpipr gives us, what is it going to give us? Well, it gives us the averages, right? The bar chart of IMF EXP is going to produce the average over the PR variable, so over 2 possible sort of outcomes, 1, 0, 1. So let's say it again. And that's exactly what we get. So we get the average that we just calculated, also the 28 or whatever it was, and the 33 or whatever, 34. So we can make a nice sort of bar chart that has spending for majoritarian systems and for PR systems. And if you wanted, you could make this graph nicer. So the graph has an editor function. So if you click on these bars here, you can do lots of things. You could, for example, make this background, I don't know, make the background lavender. Okay, that's very ugly. Or you could make it white. Oh, that's nicer. Something like this, or you can make the bars a certain color, etc. But we don't care about that right now. So let's close this again. And that's basically what I wanted to show you. Maybe one more thing to show you would be we used the kernel density estimator, which was this weird thing that gave us a smooth distribution, basically, right? So we used this before here, k density IMF EXP, which gave us sort of a smooth version of the distribution of government spending. But what we can do now also, since we've learned the if command, right? So this if condition, so do it only for certain cases if certain conditions hold. Well, what we can do, of course, is do the same thing, k density IMF EXP, if what? If, for example, DPI PR equals 0. So we could look at what that looks like, and we could do the same for 1. But it would be even better if we could overlay this, and we can. So what we can do is we can use sort of the extended graph commands, which is basically called two-way, and then we put into parentheses the command we just k density. IMF EXP if DPI PR equals 0. Right, so remember the double equal sign, yeah. And then k density IMF EXP if DPI PR equals 1, close parentheses. And let's hit enter, see what happens. And we basically get both of these distributions. So if you, by the way, lost these weird 100+% spending of GDP countries because they were non-democracies. And so basically what we see here is sort of the distribution for non-PR, I think in blue, and PR countries in red, in terms of government spending. And we can see quite clearly that countries with a proportional representation system have, on average, sort of higher government spending. What I would like you to do now is I would like you to keep Stata open once you've worked through these commands that I've used. You can also recover all your commands on the left here in the command window. So they're all here. So you can, for example, could copy paste all these into a text document or something, so that you have the things that you've done. And it makes sense to write notes about what you have done as well, because in a few days these will seem sort of meaningless to you. So I would very much recommend you copy pasting these commands into a text document and so on. And I'll say a couple more words about what else you can do with that later. But save your commands basically. But what I would like you to do after you've worked through the same sort of steps that I have done is I would like you to go back to the codebook and keep your Stata instance open basically, and go to the codebook and have a look what else is in here. This is a very rich sort of data source that has lots of interesting things on health and on military service and on military spending and on parties and on judicial institutions and labor market and media. So lots of things in it. And basically what I would like you to do is have a look around in the codebook if there's anything you find interesting. There must be something. There's from climate change to media to spending data to military data, lots of things. And basically have a look whether people booked holiday and holiday accommodation over the internet. Okay, I'm not sure how good the coverage of that is. I think it's EU countries only. But basically have a look at whether there's anything you find interesting, and maybe make some simple graphs and sort of summarize the summary statistics and these kind of things. Sort of explore the data set a little bit, see whether you can use the commands that you've learned today. And that's basically the task I have.